What's up, 10-3? Hopefully you guys have already watched the previous video on area. Now we're taking that a step further and looking at area of three-dimensional shapes, which is called surface area. If you're following along in the note package, a lot of this is based off of pages 23 and 24 in the note package. So first of all, we're going to look at some terminology. So what is surface area? Well, surface area is the total area of all faces of a three-dimensional shape. So be looking at like a tissue box and figuring out what's the area of the top, bottom, left, right, front, and back. Adding that all up will give you the total area of that, which is called your surface area. And so understanding and being able to calculate surface area is quite applicable. People use it a lot in trade, so if you're looking at, calculating the amount of material you might need to create something, or paint something, or coat something, we need to be able to understand those processes. Another piece of terminology we need to understand here on top of like what surface area is what a geometric net is. And so a geometric net is a two-dimensional pattern used to construct a 3D shape. Now, what that means is if you took, for example, again, your tissue box and you cut it out and you unfolded it, you would be left with a two-dimensional pattern that had originally been constructed of that three-dimensional shape. And understanding a geometric net gives us a little bit of better understanding of how we can create a surface area formula. So let's go look at a few different shapes. Today we're focusing strictly on prisms. And so this is the first type of prism, and it's a particular type of prism. Hopefully you know what shape that is. That is a cube. So looking at this shape here in red, that is my three-dimensional shape. And if I kind of finish this or think about what's happening here. Okay, we can see these sides, but remember there's also like that three-dimensional shape where there's also sides back there that we can't see because it's in 3 dimensions. So that would be like looking at a Rubik's cube. Now, if I take that and I unfold it, we would be looking at a net. So the geometric net of a cube would look something like this. And that should make sense because if I'm looking, there's this top, a bottom, a left, a right, a front, and a back. So there's 6 sides here. Now, because those are all squares, when I unfold that, I have 1, 2, 3, 4, 5, 6 squares. And often we have different ways of creating this 3D net, but as long as you understand that that can fold up and create this cube, then that's good. So now we need to be able to, say, what's the surface area formula for a cube? Well, we just said there are 6 of those times by, what's the area of 1 square? Well, a square has all the same side lengths, so rather than going length times width, we say side times side. Now, this formula isn't on your formula sheet because technically you can use the surface area of a rectangular prism, but if you want to write that down for yourself on your formula sheet, I would go ahead and do that. To figure out the surface area of a cube, we can just use 6 times side squared, which is 6 times side times side. Let's look at another shape. So that shape right there is a rectangular prism, and so that would be kind of like our tissue box that I was talking about. And again, remember that looking at this 3D shape, there is also those 3 other sides behind there that we can't see. So if I unfold that 3D shape, I would end up with some sort of net that looks like that. And this should make sense because I have, the front and the back, which would be this front and the back. I would have, let's go with the top and the bottom, which is the top and the bottom. And then that's also made up of the left side, which is this side right here, and the left side, which is right here. So the left side and the right side. And you may have already looked at this formula before, and hopefully you can realize, well, this is made up of how many different shapes? This is actually made up of 1, 2, 3, 4, 5, 6 rectangles. But they aren't all the same rectangle. They're 1, 2 of the same, 1, 2 of the same, and 1, 2 of the same. And so we have a formula that can help me figure out the information for this. So if I look at this rectangular prism, and I'm going to call this the length, this the width, and this the height. So this is the length, the width, and the height. When I add all of those rectangles up, I'm left with this. So the surface area of any box or of any rectangular prism, so you can also use this for a cube, is 2 length width plus 2 length height plus 2 width height. And that accounts for the top and bottom, the left and right, and the front and the back. That formula is on your formula sheet. The other shape we're going to look at is this right here, and hopefully you know what three-dimensional shape that is. That is a cylinder. And so that's our 3D shape. If I cut that and I create my geometric net, it would look like the image there on the right part of your screen. Now, this one's a little bit trickier, is I'm technically making this up of 2 circles. So this one on the top and this one on the bottom, right? Plus the rectangle. And even though, like, you know, you look at a pop can, you kind of don't really realize that this is made up, the side or the wall of the pop can is made up of a rectangle. That's all the way around here would be made up of a rectangle. Now, I can't just figure out length times width for that. So we actually have a particular formula here that the surface area of the cylinder is equal to 2 pi r squared plus 2 pi r h, where r is the radius and h is the vertical height of the cylinder. And you need to be using r, not diameter. So if you're given diameter, divide that by 2 to use your radius. So let's take these formulas and kind of sort of understanding them, apply them to some questions. So this one here says, determine the surface area of the shape below. So the first thing I always do is I look at that shape and say, okay, that is what shape? Well, we could call that a box, or we could call that a rectangular prism. So surface area of a rectangular prism. And the reason I write that for myself is because then I can go to my formula sheet and find the formula. So 2 length width plus 2 length height plus 2 width height. And all I need to do is multiply those all together. So let's call this the length, this the width, and this the height. So to substitute into here, 2, now when I write these 2LW, there's really an invisible multiplication sign in here. So 2 times the length, which is 11, times the width, which is, the width, which is 5. Now I got to keep going. Plus, and that's really giving me the area of the top, the top and the bottom for this one. Now let's do the next part. 2 length height. Now length and height are going to be giving me this front side and the back side here. So 2 times the length of 11 times the height of 6. I just substitute those numbers into the formula. Plus, the last part of the formula is width height. And so width and height are giving me these outside left and right rectangles on here. So plus 2 times the width of 5 times the height of 6. And then I need to just take all that and put it into my calculator. So 2 times 11 times 5 plus 2 times 11 times 6 plus 2 times 5 times 6 gives me the total surface area of that rectangular prism is equal to 302 centimeters squared. Because I'm still talking about area, I need to include my units, and it's just a calculation of a total area of a 2D shape. So our final unit is in centimeters squared. Okay. Next one says, determine the surface area of the shape below. Again, usually they don't tell me which formula I'm going to use or what shape it is. So I look at that. I should be able to tell that's a cylinder. So surface area of a cylinder. I go check my formula sheet, and the formula sheet says you can use this formula 2 pi r squared plus 2 pi rh. So 2 pi r squared plus 2 pi rh. Now I just need to make sure I know what h is and what r is and substitute them accordingly into the formula. Well, they literally tell me here the height is 21. So anywhere in this formula there's an h, I'm going to put a 21. However, they are giving me the diameter is 10 feet. What I need to do is look at the radius. And so the radius is equal to 5 feet, right? Because radius is half of the diameter. So now I'll take the height and the radius and substitute them into here. So 2, now again, when these are all next to each other, they're really just being multiplied. So 2 times pi, and if you don't have the pi button on your calculator, just use 3.14. Oops, times pi, times the radius, which is 5 squared, times 5 squared, plus 2 times pi times RH next to each other. So, pardon me, those are just going to be multiplied times 5 times 21. So 2 times pi times 5 times 21. Put that all in my calculator. I can put it all in at once if I want. And that should give me the total surface area of 816.8. And my units are feet, so that's going to be feet squared, because we're still talking about an area, a two-dimensional area. Right? That'd be like taking that object and trying to paint the whole outside of it. That's what we're talking about when we're talking about surface area. Do I have another question here? Yeah. All right, so the next one says determine the surface area of a cube if the side length is 5 centimeters. So they tell me that I'm doing a cube, so surface area of a cube from before is 6 sides squared. They literally tell me the side length is 5, so wherever there's an S, I'm now going to put a 5. So that's going to go right there. So 6 times 5 squared. 6 times 5 squared on my calculator gives me 150. The units is centimeters, so centimeters squared, because we're talking about area. All right. Last question here for this video said, what would be cheaper to manufacture? A cylinder with a height of 15 inches and a radius of 12.7 centimeters, or a cube with a height of 15 inches? So this question is actually twofold. So I'm just going to split my screen in half. So we got to do a surface area of a cube, which we know is 6 sides squared. And we have to do surface area of a cylinder, which is 2 pi r squared plus 2 pi rh. Again, I'm just grabbing those from the formula sheet, and because it told me what shapes here, I'm just writing their formulas down. That's usually where I start. So let's see if we know what r and h is before we start plugging numbers into this formula. So it says a height of 15 inches, so h is equal to 15 inches. This one says a radius of 12.7 centimeters. Now, that's a little bit of a problem for me because I need all of the units to be constant, okay? So what I need to do is change that to inches. So from our previous lesson, we know that in 1 inch, there are 2.54 centimeters. So I got to take this and divide it by 2.54. So 12.7 divided by 2.54. So the height of that, the radius is actually just equal to 5 inches. Now I know my height and my radius, I can substitute that into here. So 2 times pi times the radius of 5 squared plus 2 times pi times the radius of 5 inches times the height of 15. So I'll take all of that and put it on my calculator. Plus 2 pi 5 times 15. Oops, that's 12. Oops. So the surface area of the cylinder would be 628. I'm just going to leave that as a whole number. Centimeters squared. So that's for the cylinder. Now let's do the same thing for the cube. So the height of the cube is 15 inches. So if that's the height, that means every single side length is going to be the same. So really that's just what S is equal to. So I'll go 6 times 15 squared. So 6 times 15 squared is 1,350 centimeters squared. So if I have to pay for my material, am I going to want to make this cylinder or am I going to want to make my cube? Well, the cube costs more in terms of surface area, so I'd want to probably create the cylinder if I'm trying to save money. All right. So try some homework on pages 26 and page 27. In the homework and in my notes, I included triangular prisms, and I realize that's a little bit difficult to do from afar, so I'm not going to get you to do those questions. They're also not on the quiz. So do some practice questions, and when you're ready, attempt the quiz. And if you have any other questions, feel free to send me a message on Remind. Thank you.